So in this topic we will discuss the liquid extraction process. So what is liquid extraction process? It's simply a mass transfer operation in which a liquid solution is contacted with another liquid solvent, and with the help of these liquid that can be separated out, that liquid solution is separated out. This liquid extraction process is also known as a solvent extraction process, where because we have to add a second liquid that is also known as a solvent. So in other words, this is a separation of substances from a mixture, from a liquid mixture, because of the solubility nature. So as far as the application is concerned, it is a very useful process in so many industries. For example, in the nuclear processing, it is very much useful for the purification of the uranium. In ore processing, it can be used for the purification of metals such as nickel, and in the production of the fine organic compounds, in the production of perfumes. In the refinery and chemical processes, it is also useful for the removal of the aromatics from the kerosene based oil, and also it is useful for the separation of aromatics from paraffins, from naphthenes. So overall, it is one of the very useful process in the industry. Liquid extraction process can be explained by this diagram. Say for example, we have a solution that is our feed, in which solute A is there and solvent B is there. Then we have to add a next solution, or you can say solvent, that can be denoted by C. After adding, we have to go through the thorough mixing. After mixing, we will observe that there is a two phases of the liquid, phase 1 and phase 2. So these two phases are obtained because of the mixing of solvent C with the feed in the after thoroughly mixing. Now let us see the other parameters about the liquid extraction. The first is, in the feed there is a solvent B and also there is a solvent C. So we have to differentiate these two solvents by their name. The C solvent is known as the extractive solvent because it is used to extract the solute from the feed, and solvent B is also known as the carrier solvent because it is a carrier, act as a carrier for the solute A. And these two phases are also named as, one phase is extract phase and one phase is raffinate phase. Extract phase, where basically extractive solvent is taken the material from the feed, the solvent rich solution containing the desired extract solute, and raffinate phase is the residual feed solution left after. What happens if solvents is added to a solution? Let us explain with the help of diagram. The first possibility of adding these solvent in the solution is complete miscible. For example, if there is a feed of a solution where solute A and solvent B is there, and we are adding a third material that is a solvent, and after mixing of these solutions with the solvent, we can get a homogeneous mixture of A, B and C in a single phase. So this is the situation where complete miscible solvents are there. This is of no use for the liquid extraction process. Come to the second option, that is a completely immiscible solvents. What it means that, for example, this is our feed where solute A and solvent B is there. We can add a third material, that is a solvent C, in this one, and after mixing, what happened, there is a two distinct phases, and these two distinct phases only A is distributed, C and B solvent, that is carrier solvent, both are immiscible. So what happened, we can obtain in phase 1 only an A, B are there, in the phase 2 C in the solution. So this is a two completely immiscible phase. The third one is that is useful for our calculation, that is a partially miscible solution. In this case, if suppose we have a feed of solute A and solvent B, we add a third material solvent C, and after mixing we can get a two phases. In the phase 1 we have all these three materials, means A, B and C solution. In phase 2 also we have A, B and C solution. So the difference between these two things is that because B and C are the solvents, so in one phase C is high. For example, in phase 1 C is high, in the second phase B is high, in the phase 2. So C high means extractive solvent solution, B high means raffinate phase. So this is the case of liquid extraction, where we are going to discuss the different types of the